Hi everybody, I am Mrs. Morandi and welcome to this makeup lesson on solving two-step equations. Before you do this lesson, you should have already watched using addition and subtraction to solve equations and using multiplication and division to solve equations. This class is going to put all of those together in a two-step equation. Please be sure to have your math notebook and your pencil ready. So today we are going to review some keywords, our inverse operations that we use to solve our equations, and then we're going to use the additive inverse and the multiplicative inverse operations to solve two-step equations. So let's look at what our equations are. You can think of an equation like a balanced scale. As long as you perform the same operations on both sides of that equation, you don't change the value of the equation. So we use the inverse operations on both sides to be able to solve for our unknown values. Our inverse operations are operations that reverse the effect of another operation. For example, addition and subtraction are inverse operations. And then multiplication and division are inverse operations. Take a moment to write these notes down in your math notebook and unpause when you're ready to move on. So let's do a quick review of one-step equations using these inverse operations. In our first example, we have x plus 15 is equal to 30. So we want to do the inverse of plus. So to solve this, we would subtract 15 from both sides of our equation to solve x equal to 15. Always plug in your answer so that you can check your work. 15 plus 15 is equal to 30. X minus 20 is equal to 40. The inverse operation of subtraction is addition. So if you add 20, you're going to just get x on this side, add 20 to this side to solve x equal to 60. And again, if you plug in your value for x, subtract 20, you get back to your original answer. Now these two examples use our multiplicative inverse. In this problem, we have 2 times x equal to 20. So we do the opposite of multiplication and solve x equal to 10. 2 times 10 does equal 20, so again we are correct. And finally, y divided by 9 is equal to 10. A lot of times you'll also see it written like this. Y divided by 9 is equal to 10. You do the opposite of division and you would multiply both sides by 9. These cancel out. Y is equal to 90. And plugging in that value, 90 divided by 9, will get you back to 10. So let's take these simple equations and let's go a step further. When you're solving two-step equations, the first step you're going to do is you are going to add or subtract. You want to get to a point where you have your variables on one side of your equation, all by just the variable attached to the number, and then your numbers on the other side of your equations. So then you can do step 2 where you multiply or divide using your multiplicative inverse. You can do this step first, and I'll just show you what you have to do if you're going to do it. It's easiest to solve using the addition or subtraction first. Here's my tips for solving two-step equations. Read the problem out loud. When you're reading it out loud, you can identify what operations are being used so you can more easily select the inverse operation you're going to need to solve it. So in this problem, 4 times x plus 6 is equal to 42. In this problem, I'm multiplying and I am adding. So to solve, I'm going to have to divide and I'm going to have to subtract. I want to do my subtracting first and then my division. So it's almost like a machine, if you can think of it. You're moving down this way and you are multiplying and then adding, and so then to work your way back to the answer, you're going to subtract and then divide. So if we subtract 6 from both sides, again, I'll put my little line here to show we're keeping this balanced. I get 4x is equal to 36. Now I can do my step 2, multiply or divide. Since I have 4 times x, I do the inverse of multiplication, and I solve x is equal to 9. I'll plug in my answer, 4 times 9 plus 6, and see what that equals. I do my order of operations, multiply first, and then add, and yes, I get back to 42. Let's look at this same problem, but what would happen if we multiplied or divided before we add or subtract? So I have 4x plus 6 is equal to 42. If I am going to divide by 4 first, then I'm not only going to have to divide 4x, but I'm going to have to divide 6, and I'm going to have to divide 42. I'm going to need to divide all of these numbers by 4. So now I simplify, and I would get that x plus 6/4 is equal to 42/4. Keep it in fraction form, because then when you go to do your additive inverse, your denominators will be the same and you can subtract. So I can subtract 6/4 from both sides, and I would get that x is equal to 36/4, which when you divide 36 by 4, you do get 9. So you can see if you do it either way, you'll still come up with the correct answer, but when students do the multiplying or dividing first, they forget that you have to do it to all of the numbers. So I highly recommend, and the way that I will show you the rest of the examples, is adding or subtracting before you multiply or divide. So here is another example. Again, I have my tips listed here for you. Read the problem aloud, identify the operations, and select the inverse operations you're going to use. So I'm going to read this problem aloud. I have 3 times x plus 5 is equal to 20. Now I identify what operations are being used. I am multiplying and I am adding. So to solve this problem, I'm going to have to subtract and I'm going to have to divide. I'm going to subtract 5 first, simplify to get 3x is equal to 15. Notice how I just have my 3 variables, 3 times x, on one side of my equation, and my number all by itself on the other side. This is a nice simplified problem for us here. Now I do my division step. Divide by 3, and I solve that x is equal to 5. Try this next problem on your own. Unpause the video when you are done. And welcome back. So, reading the problem aloud, 2 times x plus 16 is equal to 32. So just like in the last problem, you needed to subtract first, then you needed to divide, and you should solve that x is equal to 8. Plugging in that value, 2 times 8 plus 16, you get 16 plus 16, which is equal to 32. So on this page, I have 2 more examples for you, along with the notes reminding you to add or subtract to isolate the variable, then divide to solve for your unknown. Always remembering whatever you do to one side, make sure you do to the other. Write both of these problems in your math notebook, solve them on your own, and unpause the video when you are finished. And welcome back. So, I like to again put my dividing line down here to remind me whatever I do to one side, I need to do to the other. So I subtract 5 first, and then I need to divide by 2 to solve that x is equal to 5. Plugging in for the value of x, I can see that by x equaling 5, I do get a balanced equation. In my second example, 3 times x minus 5 is equal to 7. So this time we had to add and we had to multiply and subtract. So to solve, we're going to add and divide. And you can see here I've added 5 to both sides, divide by 3, and I solve x is equal to 4. Plugging in for my value of x, I can check my answer that it does equal 7. Now what I'd like to show you is how you can apply these same steps to solve problems that have decimals. So looking at this first equation, I have 5 times x minus 15 is equal to 25. So I'm going to first do the opposite of subtraction. I want to add, rewrite my problem. Again, let's keep us lined up right here. Now I can divide, the opposite of multiplication, divide both sides by 5, and I solve that x is equal to 8. 5 times 8 is 40. 40 minus 15 is equal to 25. So now I have 0.5 times x minus 1.5 is equal to 2.5. My decimal place moved the same number of times in all 3 of my numbers, so my answer is actually going to come out to be the same here. I just want to show you how you can use the same steps that we've been using to solve these other problems to solve for our unknown here. So let's give ourselves a dividing line right here. 0.5 times x minus 5. So I'm going to be dividing and adding to solve this problem. I'm going to start by adding 1.5 to both sides. When I add decimals, my decimal place is lined up. It should be lined up in my problem all the way down into my answer. Then I add, once I place my decimal here, I just add my numbers together. 5 plus 5 will give me 10. That'll carry over, and I get 4.0. All of this is still equal to our 0.5 times x. Now I just divide both sides of my equation by 0.5. And again, for this to equal 1, you need to divide by the exact same number. 0.5 divided by 5 is not going to equal 1. 0.5 divided by 0.5, it's what's going to help you isolate x. Now, to solve the rest of my problem, I need to set up 4.0 divided by 0.5. My decimal in my divisor needs to be moved because this needs to be a whole number. I move it 1 time, so I move this decimal 1 time, and I know my decimal in my answer is going to go up here. 40 divided by 5 is 8, so my answer is 8. Let's have you try this problem on your own. I will read it aloud and then figure out the steps you'll use to solve this problem. 0.5 times y plus 0.3 is equal to 0.5. So use your inverse operations of these operations up here to solve for our unknown y. Unpause the video when you are done. And welcome back. So using my inverse operations, I needed to first subtract 0.3 from both sides, keeping my decimals lined up to get 0.2. Divide both sides by 0.5. When I set up my division problem, 0.2 divided by 0.5, I need to move my decimal place 1 time in each problem. Then when I divide 2.0 by 5, I would get 0.4. To check our answer, let's try to plug in that value of 0.4 as y to check our answer. So I have 0.5 times 0.4. This will give me 20, and I need to move my decimal place 2 times, so I end up with 0.2. 0.2 plus 0.3 equals 0.5, and yes, I am correct. Well, thank you for watching this makeup lesson on two-step equations. Be sure that you print the assignment that is attached to this video. It will have mostly regular two-step equations without decimals, but I did throw a couple decimal ones in there for you to practice those too. So make sure you return it to your teacher and have a great day.